Hello, welcome to my channel. So in this video, I'm going to show you how to find the resultant vector, or sometimes it's called the net vector, when several vectors are given. For example, here we have five uh, force vectors acting on point A, and we want to find the resultant vector or the net vector that can replace all these five vectors. So let's say that we have an xy coordinate system. So I'm drawing the xy coordinate system here. This is my positive x direction, and this is my positive y direction. I'm going to assume that the resultant vector has a size given by f sub r, and it's going to make an angle theta with the positive x direction. So the objective of this problem is to find the magnitude of f sub r and the magnitude of the angle theta. So the first thing that we need to do here is resolve all the vectors along two perpendicular directions. That means along the x direction. So you can see this is our positive x direction, and along the y direction, positive y direction. So I'm going to now figure out all the components along the x direction. So this is how we represent that. So this is this symbol for summation. So I'm going to sum up all the components along the x direction. Okay. So I'm going to first start with this one, 12 square root of 3, and that's exactly along the x direction, so there's no y component for that. So I'm going to write 12 square root of 3. I'm not going to write the units. And then I'm going to go counterclockwise. The next one is these 5 newtons in the first quadrant. So how do we find the x and the y components for these 5 newtons? So I'll show it over here on this side. So let's say that we have that 5 newtons. I'm going to have it as the hypotenuse of a right angle triangle. I'm going to create a right angle triangle where that 5 Newton force is the hypotenuse. So then you can see with the geometry, this angle, this is that same angle over here. So that's going to be 30 degrees. That's 30 degrees. So the y component of this 5 Newton force is this one, and the x component is this one. In other words, if you consider 5 newtons as the hypotenuse, yi is the opposite side and xi is the adjacent side. So the way to find the opposite and the adjacent is to use sine and cosine definitions respectively. So if I go with sine theta, or in this case it's 30 degrees, I will have opposite, which is yi divided by 5. And then I'll get yi as 5 sine 30 degrees. Similarly, cosine of 30 degrees is equal to xi divided by 5. In other words, xi is going to be 5 cosine 30 degrees. So that's how you are going to resolve all the vectors along the x and the y direction. You're basically going to use sine and cosine. So coming back to the original problem where I'm trying to find or summing up all the x components and summing up all the y components. So I'm about to get all the x components. So I have the first one, 12 square root of 3. Then 5 newtons will have an x component, 5 cosine 30. And then I'm going to 16 newtons, which is in the second quadrant. You can see that's going to have an x component in the negative direction. So I'm going to write, as a result, I'm going to write negative 16, and that's similar to the phi one. That's going to be cosine 30 degrees. Okay. And then I'm going to the next one, which is 8 newtons. That is directly along the negative y direction. So there's no x component for that. Okay. So we don't need to worry about that. Then we come to the 5 newtons in the fourth quadrant. There again, it will have a positive x component given by plus 5 cosine 30 degrees. Okay. And then I need to sum this up. So I'll have 12 square root of 3. I have all the other three terms, they have cosine 30 degrees. So I have 5 and 5, that is 10, minus 16. 10 cosine 30 minus 16 cosine 30 will give me 6 cosine 30. However, if you look at this table over here, cosine 30 is square root of 3. So I can substitute for cosine 30 square root of 3 over 2. Square root of 3 over 2. And then finally I'll get 6 and 2 cancels out. So that's going to be a 3. So 12 square root of 3 minus uh, 3 square root of 3. So the answer would be 9 square root of 3. And now I'm going to put the units newtons. So the sum of all the x components, that's going to give us 9 square root of 3 newtons. And similarly, I'm going to look at all the y components. So there's no y contribution from 12 square root of 3 because it's along the x direction. The 5 newtons in the first quadrant, that's going to have 5 sine 30 degrees. And that's in the positive direction. 16 newtons, that's similar to 5 newtons. That's going to have, again, in the positive direction, 16 sine 30. And then 8 newtons, that is directly along the y direction, negative y direction. There's no x component, so I'll have to use that 8 newtons, but it's in the negative direction. So that's why I'm putting a negative sign, because I consider up as the positive direction. So then down is going to be negative direction. And then coming to the 5 newtons in the fourth quadrant, that's going to have, again, a negative y component. So negative y component, that's why I put a negative sign. The component would be 5 sine 30 degrees. And then I need to find out the answer. You can see positive 5 cosine sine 30 and negative 5 sine 30, they will cancel out. Sine 30 is 1/2, so 16 times 1/2 minus 8, that's going to be 8 minus 8, which is 0 newtons. So you can see there's no net y component in this problem. The entire component is just the x component. So finally, we can find out the magnitude of the resultant force or the resultant vector. I'm going to use the definition, but the answer is obvious in this example, but I'll still use the definition. We are going to sum up all the x components squared and then add that to the summation of all the y components squared. Okay. Now, y components are 0. So we'll just have the x components. So we'll have 9 square root of 3 squared, that entire term squared, plus 0 squared. So the answer obviously is square root of a square is just that number, 9 square root of 3 newtons. That's going to be the answer, the magnitude. And then theta, the angle, again, I'm going to use the definition to find the angle inverse tangent, the sum of all the y components divided by the sum of all the x components. But here again, since the sum of y components are 0, I'm going to have like 0 angle, okay, 0 theta. Theta will be 0. So then that's going to be 0 degrees. Okay, so theta is going to be 0 degrees. Which means that the net force is along the x direction. The net force is going to be along the x direction. So I will replace this information now over here. For example, I'll make a slight adjustment. I'll just replace this. Now that we have our x and y components, we now have an understanding about the net force. So the net force is basically directed along the positive x direction. Okay, that's the direction. That's why we have theta equals 0, and the size Fr is simply going to be 9 square root of 3 newtons. Okay, so that's the size and the direction of the net force. And this is how you do this particular problem. Thank you for watching this video.